to triangles. The older you get, the more technical everything becomes, and a triangle is no longer a triangle. Now, if you were to break it down by its definition, tri means three, and angles are like measures, acute, obtuse, right? So this is a shape that has only three angles. Now, once you get into it, you can start judging triangles by their angles. So if you have an acute triangle, this has all acute angles on the inside. So a triangle that looks like this. If I was to take this angle, it's acute. This angle, it's acute. This angle, it's an acute angle. Because all of these angles are acute, that makes it an acute triangle. Going down here, for your right triangle, it has two acute angles, and one right angle. So you might have something that looks like this. Here's your right angle. It's right over here. And then it's accompanied by two acute angles. Now it could be pointed any direction. It could look like this, or it could look like this. As long as it has one right angle and two acute angles, it's a right triangle. And then an obtuse, which I always mess up drawing, but I'm going to try my best. It has one obtuse angle. So it has one obtuse, which is found right here. And it has two acute angles, which are found over here. So that's how you can classify triangles by their sides. You either have the first way, which is the acute angle, the second way, which is a right triangle, or the third way, which is an obtuse triangle. Now let's hop into the sides. You have scalene, isosceles, and equilateral. A scalene has no, how if I drew one better? It has no equal sides. If I was to measure all of the sides, they would be of different lengths. So say I have something that looks like this. This side is shorter than this side, and this side is shorter than this side. So that is a scalene triangle. If I was to measure it out, they're all different lengths. Then you have an isosceles triangle where it's two equal sides. And let's say we drew this right triangle, and we said that these two sides over here were equal. A lot of times they're going to draw lines inside of it showing that they are equivalent in length. So those two sides are equal. Sometimes they'll draw two lines. If it has the same amount of dashes in it, that means that they're equal. And then the last one is not no sides, not two sides, but it's going to have all equal sides. And it might look something like this. If I was to measure it, this side and this side and this side are the same length. So that's an equilateral triangle. So the three ways you can judge them by their sides are scalene, isosceles, and equilateral. Now how we have all that information, can you do it with both? Yeah, let's go do a couple example problems. So what I gave you were these two triangles. If I just look at the angles here, here, and here, or this angle, and this angle, that's definitely a acute triangle. And if I looked at the sides, they told me right here that they're the same length. So that's an equilateral. So this is an acute equilateral triangle. This next one, it doesn't say any of the sides are the same length. So that kind of prompts my thinking one way. But let's look at the angles first. I have one right angle. That clues me in with two acute angles. That means it's a right triangle, and it's also a scalene triangle because all the sides are different in length. So it's a right scalene triangle. And the last one, okay, it's going to take a little bit of figuring. I have two acute angles right here. And then I have this one that looks very much opened up, so that tells me it's an obtuse. So if I have two acute and one obtuse, that's an obtuse triangle. Let's judge it by its sides. It says that these two shorter sides, right here and right here, are the same length. So that must mean it's an obtuse isosceles triangle. So that is how you can judge triangles, by their sides, by their angles, and then by their both.